Today in Algebra 2, we talked about roots of polynomials and their corresponding factors. We actually talked about the Factor Theorem and how to figure out, if I know that I have a root of 5, for instance, that means I have a factor of x minus 5. Like, for instance, if I know one of my roots is 1, I have a factor of x minus 1. But what if my roots are more complicated than that? What if my roots are more like, and I was trying to zoom in, sorry, I can't, square root of 10, or 3 plus 2i. Well, there are a couple of things that we went over, and the two basic things we talked about today are, number one, find all additional zeros, knowing when there are more zeros just based on the zeros that you know. In other words, more roots based on just the roots you know. For instance, if I know that I have negative 3 plus root 5, then I also know that I would also have a root of negative 3 minus root 5. It's basically the conjugate. Change the sign of the radical part. And if I have positive 3i, well, remember, I is really a radical. It's square root of negative 1. So same thing goes there. If I have positive 3i, I'm going to have negative 3i. If I have 1 plus 3i, I'm going to have 1 minus 3i. If I have negative 3 plus root 7, I'm going to have negative 3 minus root 7, and so on. All right, so on this section up here, excuse me, they're telling me some of the zeros. My job is to find the ones they haven't told me and then to write the corresponding factors. So the second part of what we're talking about is, now that I know I have these two roots, how do I write the factor that I would have solved equal to 0 to be able to get these? How do I write the factor that goes with those two roots? And that's a little bit more complicated. Okay, so we did that today. Basically, we talked about how, let's go ahead and do number 9. Okay, number 9, the roots that I know are, I know that x is 3 plus 2i, and I know that x is root 10. Well, that also means automatically that x is 3 minus 2i, and that x is negative root 10. So I know I've got at least 4 roots. Usually what you'll be asked for with this sort of problem is you'll be asked for the polynomial of least degree. In other words, if I know I have these roots, theoretically I could have 5 more roots. You know, maybe x equals 6 is a root. Just because I know these 4 doesn't mean there aren't others. But usually when they give us something like this, they're asking us to just say, just assume for a second this is all you have to go with. Let's just assume these are the 4 roots. So then this would mean it was a degree 4 polynomial. That would be my polynomial of least degree. In other words, if I have 4 roots, then I have at least x to the 4th. Okay, could be that there's another root floating around there and it's x to the 5th, or another couple and it's x to the 6th. But we're just going to stick with the simplest case scenario. So finding the factor that goes with these two. It's going to be one factor that goes with both of them, because the reason for the plus and minus is the idea that I have taken a square root. Okay, I is square root of negative 1. So if I've taken a square root, usually when we take a square root, we go plus or minus at that moment. So let's start with these two. Here's the easiest way to find the corresponding factor, is to say, okay, I'm going to rewrite that as just one phrase here, just 3 plus or minus 2i. Okay? And then I want to get that plus or minus 2i part alone, because I is under a radical. I is square root of negative 1. And because of the plus or minus, if I can square just that part, then I can get rid of the plus or minus and the I, and then I'll have just regular old numbers. So in other words, I am going to keep this part alone, move the 3. So I have x minus 3 equals plus or minus 2i. Now I have it the way I want it, because if I square plus or minus 2i, plus or minus 2, it doesn't matter which one it is, squared is going to be 4. Plus or minus I, doesn't matter which one it's going to be, which one it is going to be I squared, which is negative 1. So by squaring this, I get 4 times negative 1. On the other side, I'm also going to square. Whatever we do to both sides. But please don't forget, this is squaring a binomial. You will not get x squared minus 9 or x squared plus 9. You have to basically multiply the whole thing out. Now, you might have done it enough times that you don't actually have to go through the process, but this is what's happening. So x times x times negative 3, negative 3 times x, negative 3 times 3, negative 3, and this is what we get. So that's what's on the left-hand side here. X squared minus 6x plus 9 equals 4 times negative 1, which is negative 4. So here's the goal here. I'm going to get it to where it's equal to 0. Because anytime we're factoring to solve, we want it equal to 0, and then we say, okay, if this factor equals 0, what would I get? So we're going backwards. Factor equals 0. This is my factor. This is the factor that if I solve, set it equal to 0 and solve, I would get x is 3 plus or minus 2i. So that's what we're doing, is we're working backwards. We're seeing basically, let's think of I factor and solve. That's where you get it into factored form and set each factor equal to 0 and solve. We've solved. We're going, which factor gave me this solution? So there it is. So the factor that goes with these two, just one factor for both of them, is this. Okay? Now we're going to do the same thing for the plus or minus square root of 10. If x is plus or minus square root of 10, well, I've got the plus or minus part all by itself already. I don't have to move anything. And I could square both sides and get x squared equals, when I square plus or minus 10, that's just 10. So let's subtract, and I get x squared minus 10 equals 0. So here's my factor. So the factor that goes with those two is x squared minus 10. So if they were asking me to write all the factors I know of, here they are. These are all the factors I know of. If they were asking me to write it in factored form, which is basically kind of what we're doing on 1 through 10 here, I would say, okay, that the polynomial with those roots in factored form looks like this. Now let me point out, well, actually we're not going to worry about that right now. So that's what I'm going for number 9. That would be my answer. X squared minus 10 and x squared minus 6x plus 13. Okay, so that's what we're doing on all of these. Now on 1 through 10, it does not ask you to multiply it out. It just says find the factors. Okay, I just happen to be writing them next to each other. Numbers 11 through, let us see, 20 ask me to find the polynomial. So that means I get this guy, and then I multiply it out. So in other words, once I find all the factors here for number 11, I'm going to go ahead and multiply x minus 1 times x plus 2. And that gives me x squared plus 1x minus 2. And then I'm going to throw in that 5x minus 4. And basically, each term over here gets multiplied by each one of those. So x squared times 5x is 5x cubed. X squared times negative 4 is negative 4x squared. Then let me change colors. 1x times 5x, 1x times negative 4. So that's 5x squared minus 4x, and then negative 2 times 5x, negative 2 times negative 4. So I have 5x cubed plus x squared minus 14x plus 8. So that would be my answer if I have to write it as a polynomial multiplied out. So here's the deal. I'm not going to ask you to do that for every single one just because it's kind of time consuming. So I just did it for you for 11. On 11 through 20, go ahead and multiply out the odds. On the evens, just find the factors. Just leave it in factored form. Okay, so here I would just leave it x minus 2, x plus 4, and so on. Okay, there's one more that goes with negative 2/3. I'm not going to do it for you. Okay, now what I really wanted to make this video for was to talk to you about 21 to 30. I started to say 26. This says factor each one root has been given. Okay, so here's what we're going to do for that. Look at the root that has been given. All right, this says this. But we know if x equals negative 3 plus 2i, x also equals negative 3 minus 2i. So we're going to find the factor that goes with those two, just like we just did in the last problem. So x equals negative 3 plus or minus 2i. Move the 3 first. Don't square both sides until you have the plus or minus 2i part alone. So x plus 3 equals plus or minus 2i. Square both sides. This is x squared plus 6x plus 9 equals plus or minus 2 squared is going to give me 4. I squared gives me negative 1. I think this is the same, what do you know, same numbers. This is negative 4, so I'm going to add 4 to both sides. And I got x squared plus 6x plus 13. So there's the factor that goes with these two roots. So if they want me to factor this whole thing, they're saying, okay, you've got part of it now based on those two roots. You have to find the rest. Well, that's kind of like if I said, let's be super simple. It's like if I said, here's my original, and I want you to factor this, and one root has been given, and the root I give you is 6. Okay, well that's 6 times 4. You're just finding what multiplies by this root factor we just came up with to get this whole original polynomial. I started to say polygon, so that's why. Okay, so this times something equals that. How are we going to find out? We're going to go back to division. Can I use synthetic division on this? No, I cannot. It would have to just be x plus a number or x minus a number. So I'm going to take x to the 4th plus 6x cubed plus 4x squared minus 54x minus 117. This divided by x squared plus 6x plus 13. And I'm going to divide, long division, and see what times this times this gives me this. So factoring means basically pulling it apart into its separate factors, pulling it apart into this times this gives me what's under here. X squared goes into x to the 4th, x squared times x squared is x to the 4th, x squared times 6x is 6x cubed, x squared times 13. Subtract. These will make nothing, these will make nothing. And bring this down. So 4 minus 13 is going to give me negative 9 x squared. Let me go ahead and bring these down. Okay, x squared goes into this negative 9 times. Notice we basically skipped having a term here because these two canceled out. So it's just plain negative 9. It's not negative 9x. Negative 9 times x squared is negative 9x squared. Negative 9 times 6x is negative 54x. Negative 9 times 130 is, times 13. I was already thinking what's 10 times 30? 13. So that is indeed negative 117. So since I get a remainder of 0, that means that there's nothing left when I take these apart. So this times this equals what's underneath. So this times x squared minus 9. Now, if I could not factor that any further, I would be done. However, this particular one can be factored further. This part can't, because there are not two numbers that multiply to 13 and add to 6. But this is the difference of two squares. So x plus 3, x minus 3, and that is my answer. Okay? So again, the process for these is this. Look at the root, figure out what other root that means you have, take those and set them equal to x with a plus or minus, solve for the plus or minus I part so you can square both sides, and then you're going to get a polynomial. You're going to get a factor of this guy. Once you have one factor, you can divide it out using long division to find out what's left. Sometimes the part that's left can also factor further. Sometimes it can't, but that's where you want to leave it. Okay? On these, let's just go ahead and do odds. So I did 21 for you. I started 25 for you. You got to do 23, 27, and 29. Okay? So up here, do all of these. These are pretty easy. You know what? I'm going to cut it further. Do all of these. Do these 5. On 11 through 20, just do odds as well. And remember, I did say for the odds, I want you to write it out. So let's just do the ones where we're writing it all out. So do 2, 4, 6, 8, 10, and from then on, just odds. 2, 4, 6, 8, 10, and after that, just the odds. There you go. See you later.